Hello, guess what? This is the last lesson of the whole course. The last lesson. I can't believe it. We're finally almost done. And to celebrate, I'm wearing my special ARRL shirt. ARRL, by the way, stands for the American Radio Relay League, and it's a very famous ham radio organization. You're probably going to become familiar with it after you get your license. And in fact, you might take your technician class test. It might be given to you by people who are affiliated with the ARRL. So anyways, let's get started on this last section, which is about safety. Safety is very important, especially when we're dealing with ham radio. Because with ham radio, we're dealing with all kinds of electronics, we're dealing with all kinds of radio waves, and all sorts of complicated things that can really harm us if we're not careful. Not to mention we have giant antennas that we need to set up sometimes. Sometimes antennas are 100 feet tall, you know, and they're on a tower. We're going to talk about that later. We really need to make sure to be careful, and that's what this section is about. It's about safety. So the first thing we're going to look at today is safety in terms of electricity, meaning you do not want to get electrocuted. See, when you get electrocuted, current flows through your body, and that's bad for many reasons. First of all, it heats up your tissue. Second, it disrupts the function of your cells. And third, it causes involuntary muscle contractions. Being electrocuted is bad. You do not want to be electrocuted. So in order to make sure that electrical things are safe, some electricians who wired things in your house have already thought of things. You know how when you plug things into the wall, there's 2 or 3 prongs, you know, one like that, and sometimes one at the bottom. There's 3 prongs when you plug something into your wall. Now, when we're diagramming this in terms of electrical circuits and everything, and when they're wiring their house, wiring your house, electricians have these color-coded. So there might be a green wire, a white wire, and a red wire representing the 3 different prongs of the plug. So the green wire in these diagrams, which I don't actually have a picture to show you, unfortunately, but the green wire in these plugs is called the safety ground. The safety ground is the green wire. And the reason it's called ground is because it literally connects into the ground. And the reason for this is that if there's some sort of electricity going on that we don't, you know, and there's danger of you being electrocuted, instead of the electricity going to you and zapping you, it'll go into the ground, and the ground will absorb it. And obviously, if the ground is electrocuted, that's fine. The ground gets electrocuted all the time. So if electricity comes and escapes, it escapes into your ground instead of causing trouble in your house. Now, the way you can remember this is green for ground. The green prong is the ground plug. Green for ground. GG. Green for ground. Alliteration. All right, so to prevent electric shock, you want to use the 3-prong cords, 3-wire cords and plugs for your powered equipment and in your ham Radio Shack. So, you know, when you plug things into the wall, sometimes you have 2 plugs, sometimes you have 3. You want to use the ones with the 3 prongs. And you also want to ground everything in your ham radio station. You want to connect, even your radio, actually, you'll connect with a wire into the ground, into a little pole going into the ground. And you also want to use a ground fault interrupter, or in other words, like a fuse or a circuit breaker, which you probably already have installed in your home. This is very important. You always want to make sure you have a fuse or a circuit breaker. So the fuse, which we talked about a little before, it interrupts power in case of overload. What happens is if there's too much power going through the fuse will actually break and melt and snap, and then the electricity stops flowing, and it saves the circuit, and it keeps it from catching on fire. So for this reason, it's very important not to use a fuse that's too big. For example, we have different kinds of fuses. There's a 5-amp fuse, which stops power when it goes above 5 amps. There's a 10-amp fuse, which stops power when it gets above 10 amps. If the circuit is rated for a 5-amp fuse, you don't want to use a 10-amp fuse, because that means the circuit, it can't have more than 5 amps going through it. But if you put in a fuse too big, like a 10-amp fuse, the 10-amp fuse will let more than 5 amps go through the circuit. Like, if there's 8 amps, it'll be fine. The fuse will be like, okay, that's fine. But it's not fine for the circuit, and the circuit could overheat and catch on fire and burn your house down. So you want to make sure you use the fuse of the correct size. So, by the way, while we're talking about electricity and all these things, we also want to talk about the power supply, which is the little thing that plugs into your wall that powers your radio. And obviously, this is related to electricity and safety. So you want to be extra careful when you're working on your power supply. Say it breaks and you decide to service it yourself. Just because it's unplugged and turned off does not mean there is no electricity in the circuits, because some of these power supplies have capacitors in them. What do capacitors do? If you remember, they store electric charge. Sometimes they store electric charge even when the circuit is turned off and unplugged. As a result, even when your power supply is turned off and unplugged, if you touch the circuit, you could still get zapped. You could still get an electric shock because there's electricity stored in the capacitors that leaves the capacitors through the circuit and goes up your hand and through your body when you touch the circuit. So you have to remember about these capacitors. And some of these things with safety, it's really just common sense. I don't even really need to mention it. Like, for example, when you're using a voltmeter to measure the voltage, you want to make sure the voltmeter is rated for use at the voltage that you're going to measure. Like, if your voltmeter can only measure 120 volts and you're trying to measure something that you know is probably 240 volts, obviously you don't want to do that. You'll break your voltmeter. Okay, so while we're at this topic of safety and electricity, I want to also mention some things about batteries. So let's say you have a ham radio battery and it's dead, you need to be able to charge it, but for some reason the power is out at your home or wherever you are. You can actually charge some batteries by connecting them in parallel with the battery in your car. And you remember we talked about what parallel means in a previous lesson. But if you connect this battery in parallel with the car battery in your car and run the car's engine, then it will actually charge that battery due to the car's built-in charging circuit. So another thing about batteries, the test will ask you about something called a lead-acid storage battery. A lead-acid storage battery. This is a type of battery. So you need to be very careful with these lead-acid storage batteries. I mean, just look at the words. Lead, that's not good. Acid, also not good. You need to be very careful with these batteries. In fact, if a lead-acid battery is charged or discharged too quickly, then it could overheat or give off flammable gas or even explode. And obviously that's not a good thing. And another thing with batteries, they have positive and negative terminals, right? Like if you've ever seen your car battery, there's a positive terminal, there's a negative terminal, the car hooks up to those terminals. Don't short the battery terminals. Like never say, what happens if I connect the positive battery terminal to the negative battery terminal? Because if you do that, you're going to electrocute yourself and damage the battery. Don't short the battery terminals. That's what we call them. Don't touch them to each other without them powering something in between. All right, so 12-volt batteries, a lot of 12-volt batteries, which is, by the way, a lot of volts for batteries. AA batteries are 1.5 volts. So 12-volt batteries are a pretty big deal. And this is actually the type of battery used in your car sometimes. These should often be kept outside. Like, don't store these inside in your bedroom. And the reason is because these batteries sometimes let off gas, and the gas can be dangerous. You want to make sure they're outside so the gas can ventilate off into the atmosphere or whatever. All right, so now let's move. We're going to shift gears. We're still going to look a little at electricity, but we're going to transition into the section of antennas and antenna safety. But we're still also looking at both electrical and antenna safety. So one thing that should be obvious, when you're setting up your antenna, be careful of electrical wires from utility poles. Like if your house, if there's a utility pole next to your house with power lines and everything, make sure that you avoid those when you're putting up the antenna. The last thing you want is for your antenna, your metal antenna, to fall on the power line and have electricity flowing through your antenna and going into your station and into your house and burning your house down. So if the antenna falls, it shouldn't come within 10 feet of power wires. So you have to think, if the antenna falls, I have to make sure it won't come within 10 feet of the power wires. I actually have I think it's my grandpa's brother is a ham. Anyway, he recently got back into ham radio after taking a break for a while, and he set up an antenna sort of on a ladder, but he neglected to follow this rule about being 10 feet away from power wires. So as a result, one night, luckily he's at home, there's a very high wind and his antenna falls off of the ladder. I don't know how he set it up on the ladder. Anyway, it comes in contact with the power lines and power goes through his antennas and into his ham shack in his room, and it sends high voltage electricity through all his equipment, all his brand new radios and everything, and it actually starts a fire in his ham shack. Luckily he was home and he was able to put the fire out and no one was hurt and nothing was really damaged except the equipment, which he had to get sent to be repaired. Anyway, the moral though is you need to be really careful with these power lines. Another obvious thing, don't attach an antenna to a utility pole. Some people actually have this idea. I mean, the antenna has to be high up. There's a utility pole right there. Why don't I just put it on top of the utility pole? Or put it, clamp it on. That's a very bad idea because your antenna could come into contact with the high voltage power wires and destroy all your equipment. So that moves us totally into physical safety and especially antenna safety. So now we're going to talk about antenna towers. So what's a tower? Well, some antennas are just vertical antennas, but we've also talked a lot about beam antennas and directional antennas, which are sort of antennas that point in a certain direction. These antennas are often mounted on towers, meaning like there's a tower that goes up like this, maybe for 100 feet, and you put the antenna on top with a little motor that turns the antenna while it's sitting on the top of this tower. Here's a little picture of towers you can look at. So this is a tower. Towers hold up your antennas. So Sometimes you may need to climb your tower in order to fix your antenna if it gets damaged, or maybe to put your antenna up. You always want to make sure to put on a climbing harness and wear safety glasses when you're climbing a tower. Now, as a technician class operator, you're probably not going to have a tower. You usually don't have a tower unless you're working on HF bands. And even then, you don't need a tower. I've talked to people all over the world. I've used a tower, my grandpa's tower, but I don't have a tower myself. Anyway, you need to be very careful when climbing these towers. In fact, you should never climb a tower at all without a helper. There needs to be someone watching to make sure he can help you if something goes wrong. And you also always want to wear a hard hat when you're working on these antenna towers. Now, some of these towers are crank up and crank down, meaning, the tower originally might be this size, but there's a crank, and when you crank it, the tower actually gets taller and taller and taller, and shorter and shorter and shorter. And this is very handy because that way, if there's a windstorm, you can crank your antenna down, or if you live in a neighborhood that doesn't like antennas, you can crank your tower down if they don't like it, something like that. So you always want to make sure to crank the tower down before climbing up it. This is for two reasons. Number one, you'll have less steps you need to climb to get to the top. But number two, it's dangerous to climb the tower when it's cranked up, because your extra weight could damage something and the tower could suddenly break and come all the way down and come crashing down and kill you or something. So you always make sure you want to crank down the tower before climbing up. So you might be wondering, how do we put up these towers? I mean, if they're 100 feet long, we can't just do that with people. What do? We use a gin pole. So a gin pole is used to lift tower sections or antennas up. So it's a pole with a pulley, and after we assemble the tower on the ground, it grabs the top of the tower, sort of like a crane, I think, and it lets you lift the whole thing up all together, and that's how you can set up your antenna tower sometimes. All right, so that concludes the section on safety, and actually it doesn't. We have this was the first video lecture. We're going to look at the second video lecture on safety in just a minute, and then after that we'll be all done with this course, except for the practice exams, the final exam, and actually taking your technician class test. So hang in there. We just have a little more ways to go. I will see you in a minute.